Hello, my name is Sophia Sardella, and I'm back again performing some practice problems with you guys for our Basic General 1 chemistry class. For this video, I'm going to be focusing on Chapter 6 of our curriculum, and in Chapter 6, the topic that I chose to focus on is going to be calculating maximum wavelength. For this problem, you are going to need a pen or pencil, a piece of paper, and then a calculator. Once you have all your supplies gathered up, we can jump in right to solving this problem. Okay, so our third problem says, what is the wavelength of energy when the frequency is 234 kilojoules over moles? Calculate the maximum wavelength of light of a single oxygen to oxygen molecule could be broken by absorbing a single photon of light. Okay, so, and we're to write our answer in nanometers. So the first step of our thing, we are going to write the equations that we are going to need. So our first equation is going to be the energy equation. It's E equals H times W thing. The H is going to equal what Planck's constant, and the thing that looks like a W is going to be our frequency symbol. So just keep that in mind while you're doing this. And our second equation is going to be the speed of light, which is represented by C. So C equals wavelength times, once again, frequency. So C, I'm just going to write it down, equals speed of light. And then we're going to write our wavelength symbol, and that just equals, and we're just put equals wavelength, just so you have another reminder of what the symbols are. And next, I'm just going to give you some numbers of what the number of Planck constant is and what the speed of light is as a given. So the Planck's constant given is going to be 6.62 times that by 10 to the negative 34. And then the speed of light is going to equal 3.00 times that by 10 to the 8th. And that's going to be meters over seconds. So now that we have that, we can start getting into our problem. The first step is we are going to find what the energy is. So we are given kilojoules, and we're going to have to convert that to joules because energy is given in joules. So the first thing I'm going to write 243 kilojoules, because that's what we have. And I'm going to write that over moles. Step 1, I'm going to use Avogadro's number in this first problem. So I'm going to put 1 mole over 6.022 times that by 10 to the 23rd. I'm going to use Avogadro's number to get into molecules instead first. So we're going to go into kilojoules over molecules. So my moles will cancel each other out. And once you put that into the calculator, you are going to get an answer that is going to equal 3.89 times that by 10 to the negative 22nd kilojoules over molecules. And writing all of the your units may seem silly and you're like, oh, it's a waste of time. It's not. It helps another way to stay organized when you're doing all your equations. Okay, next we are going to take that same number, 3.89 times 10 to the negative 22nd kilojoules over molecules, and we are going to now convert kilojoules into joules. So to do that, we know that there are going to be 1,000 joules in 1 kilojoule, so I'm going to put 1,000 joules on top, and then we are going to divide that by 1 kilojoule. And with this, kilojoules will be canceled out, and we are going to be left with joules over kilojoules. So our answer is going to be 3.89 times that by 10 to the negative 19 joules over molecules. So now that we have this, we have figured out what our E is. So I'm just going to write it down once again because I like to write it down because it helps me keep organized. Do whatever helps you keep organized. These are some of my tips and tricks. So I'm going to write E equals 3.89 times that by 10 to the negative 19 joules over molecules. Now, once we have this, we are able to start using the first equation that we are going to be using. And that first equation that we are using is going to be the energy equation. And I'm just going to write it again. Energy equals Planck's constant times frequency. So we have our E, so I'm going to write 3.89 times 10 to the negative 19 and place the E, since we already know that because we solved it earlier. So once you have that written, you're going to put it equal to, and we do know Planck's constant because that was given to us. It's going to be 6.63 times that by 10 to the negative 34. And that's all in parentheses, and then times that by frequency, which we don't know yet, so we're just going to put that letter. So in this problem, we are going to be solving for frequency. So I'm just going to rewrite it again to stay organized. 3.89 times 10 to the negative 19 equals 6.63 times 10 to the negative 34. Once again, timesing it by our frequency. Now, we are going to do some basic algebra, and we are going to divide both sides by 6.63 times 10 to the negative 34. So we are getting that frequency symbol by itself, so we know what the value of frequency is, so we can use the next equation that we are going to need to solve that problem. So once you do that, we are going to figure out that our frequency is going to equal to 5.586 times that by 10 to the 14th. So now that we have that, meters over seconds, next we are going to use our speed of light equation, which is C equals wavelength times frequency. Once again, we are trying to find wavelength in this equation. So we have C equals wavelength times frequency. We are given C, so we already know that's going to be 3.00 times that by 10 to the 8th meters over seconds. And then we're going to set that equal to, there's the wavelength symbol because we don't know what wavelength this is yet, and then times that by the frequency value that we just got. That's be 5.86 times that by 10 to the 14th, and we're going to put that all in parentheses. Once again, we are going to do some simple algebra, but we are going to rewrite it again to stay a little bit organized. So I'm going to do 3.00 times that by 10 to the 8th meters per second is equal to wavelength, and then times that by 5.86 times 10 to the 14th 1 over seconds. So now that we're here, we're going to divide both sides by that value of frequency, which is going to be 5.86 times 10 to the 14th. And you do the same on both sides, so it's even. And once you put that into your calculator, you are going to be able to find your value of wavelength. And for our equation, we found that the value of wavelength is going to equal 5.12 times that by 10 to the negative 7. And that's going to be in meters. Keep that in mind. That's in meters, and we want our answer to be written in nanometers. So we are going to have to do yet another conversion. So there are 10 to the 9th nanometers in 1 meter. So you put 10 to the 9th nanometers over 1 meter to get to cancel out those meters. And once you put that into your calculator, you are going to get the answer equals to 512 nanometers. I just rounded up to the nearest nanometer. I didn't want to go into decimals, so that's how I got my answer to be 512 nanometers. So once again, our final answer for wavelength is be 512 nanometers. Good job, you guys. And that was problem number 3.